What are Newton's laws? If you've ever slipped on ice, slammed a door too hard, or tried to stop a shopping cart that suddenly developed its own agenda, congratulations. You've personally tested Newton's laws of motion. You might not have realized it, but the universe just gave you a hands-on physics lesson and it didn't even charge tuition. Sir Isaac Newton, born in 1643, was the kind of person who could stare at an apple falling and invent classical mechanics out of it. While most of us would just eat the apple and move on, Newton decided to ask why it fell, and that single why reshaped science forever. His three laws of motion became the foundation of how we understand movement, force, and interaction in the physical world. They're everywhere, in cars, rockets, footballs, and even the way you sit in your chair right now. Let's start with the first law, sometimes called the law of inertia. It's the simplest and, in some ways, the most beautiful. It says that an object will stay at rest or keep moving in a straight line at a constant speed unless something forces it to change. In other words, motion doesn't need a reason to continue. It needs a reason to stop. Imagine a coffee cup resting on your car dashboard. When the car suddenly accelerates, the coffee cup doesn't want to move. It prefers its peaceful, stationary life. That's inertia. It resists change. And when you brake suddenly, the cup still tries to keep going forward, straight onto your clean white shirt. Inertia is both a law of physics and a universal excuse for stains. The second law is where things get mathematical. It explains how force, mass, and acceleration are connected. You probably know the famous equation F equals ma, force equals mass times acceleration. This means that the heavier something is, the more force you need to change its motion. It's why pushing a car feels harder than pushing a shopping cart. It's also why rockets need massive engines to escape Earth's gravity, not because space hates visitors, but because accelerating a huge mass takes enormous force. But this law also works both ways. If you double the force while keeping the mass the same, you double the acceleration. That's how you can make a baseball fly faster. Now, the third law, the most quoted and most misunderstood. For every action, there is an equal and opposite reaction. People say it all the time, often when something hits them back. It's not just a slogan, it's the cosmic rule of balance. When you push against a wall, the wall pushes back with equal force. When a rocket expels gas downward, the gas pushes the rocket upward. When you jump off a small boat, the boat moves backward because it's politely returning the favor. This law is the reason we can walk, swim, and fly. Your foot pushes the ground backward, the ground pushes you forward. Birds push air down with their wings, and the air pushes them up. Everything in motion is a two-way conversation between forces. Nothing moves alone. Newton didn't invent these laws out of thin air. He simply wrote down what nature had been doing since the beginning of time.